The stars are always amazing. From ancient peoples charting the skies to today's astronomers pushing the boundaries of space exploration, humanity's fascination with space remains an inextricable thread in our history. With each new discovery, our understanding of the universe has expanded from myths and speculations to rigorous scientific research. However, there is no instrument like the James Webb Space Telescope, JWST, to uncover the mysteries of the universe. Launched in December 2021, it has not only exceeded expectations, but is poised to redefine everything we think we know about space and our place in it. Imagine looking up at the sky and realizing that what you see is only a fraction of the global picture. JWST is designed to show us what lies beyond, a mission that has already produced revelations beyond our imagination. If the Hubble Space Telescope allows us to see the world with new eyes, then JWST is our window to the unknown, revealing the unseen and the unimaginable. But the deeper we look, the more questions arise. What did this amazing machine discover that sent shockwaves through the scientific community? How does it challenge long-held beliefs about the formation of galaxies, the existence of extraterrestrial life, and the origin of the universe itself? As we prepare to dive into these deep revelations, it is important to understand that this is not just another review. This is the key to the deepest mysteries of the universe. Before diving into the earth-shattering discoveries made by the James Webb Space Telescope, it's worth taking a step back to appreciate the great achievements represented by creation. For more than 2 decades, a team of scientists and engineers worked tirelessly to design and build a telescope that would not only exceed the capabilities of the Hubble Space Telescope, but would become the most advanced astronomical instrument created. The JWST story began in the 1990s when NASA and the European Space Agency, ESA, first considered the possibility of a new generation space telescope. The vision is simple but ambitious: to build telescopes that can look back in time, to the birth of the first stars and galaxies, while scanning the atmospheres of distant exoplanets for signs of life. Many technical challenges and innovations are required in the design of reflectors, heating systems, and infrared sensors. Overcoming these problems will require years of hard work, skill, and dedication to knowledge. Unlike Hubble, which captures visible light, JWST is optimized for infrared observations. This is crucial because the most distant objects in the universe, those formed in the aftermath of the Big Bang, emit light that has been stretched by the expansion of the universe into the infrared part of the spectrum. This redshifted light is invisible to the human eye and can only be detected by a telescope equipped with infrared sensors. One of the most remarkable aspects of JWST is its massive, segmented mirror, which is composed of 18 hexagonal segments that work together to form a 6.5-meter wide surface. This allows the telescope to collect more light than any space telescope before it, giving it the power to see objects that are fainter and further away than Hubble ever could. Another critical feature is JWST's sun shield, a 5-layered structure the size of a tennis court that protects the telescope's instruments from the sun's heat, allowing it to operate at extremely low temperatures. In December 2021, after years of delays and high costs, the James Webb Space Telescope will lift off on an Ariane 5 rocket from French Guiana. The destination, a point in space called the Second Lagrange Point, L2, which is 1.5 million kilometers from Earth. Here, the forces of the Earth and the Sun are balanced, so that the eye remains in a constant orbit, so that the shadow of the Earth is not disturbed. When JWST was parked, the difficult task of opening the mirrors and sunroof began. A difficult task with more than 300 points of failure, one of which would cause the project to fail. The successful launch of JWST is a miracle and marks the beginning of a new planetary era. With its unique capabilities, JWST is poised to answer some of the world's most profound questions. How did the first stars and galaxies form? Are there habitable planets outside our solar system? What is the true nature of dark matter and dark energy? One of the most exciting things about the JWST project is the ability to look back at the past. Since light from distant objects takes so long to reach us, looking at these objects is like looking back in time. The further away the object, the older the moon we see. JWST's infrared power allows it to see through the dust and gas obscuring distant galaxies, allowing us to see the universe as it was a few 100 million years after the Big Bang. In February 2023, the telescope made one of its most exciting discoveries. the discovery of 6 massive galaxies that existed between 500 and 700 million years after the Big Bang. These galaxies, which are larger and older than scientists expected for their age, have changed previous models of galaxy formation. According to the popular theory, galaxies in the early universe were small and simple and slowly grew over time by merging with other galaxies. But the galaxies observed by JWST appear to be well-formed and massive, suggesting that galaxies form much faster than we thought. This discovery has huge implications for our understanding of the evolution of the universe. If galaxies form faster than previously thought, then the early universe may have been different from current models. It also raises new questions about the role of dark matter, the invisible substance that makes it up. JWST's observations of these ancient galaxies are just the beginning. Over the next few years, the telescope will continue to explore the far reaches of the universe, revealing more information about how the first stars and galaxies looked and how they evolved over time. These findings help scientists refine their models of the evolution of the universe and provide new insights into the fundamental mechanisms that govern the universe. While the James Webb Space Telescope is revolutionizing our understanding of the early universe, it is also playing an important role in the search for extraterrestrial life. One of JWST's primary goals is to study planetary winds, planets orbiting stars outside our solar system, for signs of life. By analyzing the light that passes through a planet's atmosphere as it transits in front of its star, scientists can determine the composition of the atmosphere and look for the presence of molecules like water vapor, carbon dioxide, and methane, which could indicate the potential for life. In September 2021, just months after its launch, JWST made its first direct image of an exoplanet, HIP 65426b, a massive gas giant located about 385 light-years from Earth. While HIP 65426b is unlikely to host life, the image demonstrated JWST's ability to directly observe exoplanets, a feat that had never been accomplished before. This is a major step forward in the search for habitable worlds, as it opens the door to studying a wider variety of exoplanets, including smaller, rocky planets that could potentially support life. One of the most exciting targets for JWST is the TRAPPIST-1 system, which contains 7 Earth-sized planets orbiting a red dwarf star about 40 light-years away. 3 of these planets are in the habitable zone, the area around a star that is suitable for liquid water. Scientists have already begun using JWST to study the atmospheres of these planets and look for signs of habitability. Although it is still too early to draw conclusions, the data collected by JWST could be the first evidence of life outside our solar system. Another attractive target for JWST is Titan, Saturn's largest moon. Titan is unique in our solar system because it has a thick atmosphere with lakes of liquid methane on the surface, making it one of the few places where we can find life because we don't understand. In late 2023, JWST took pictures of Titan's atmosphere and revealed the presence of not 1, but 2 clouds, a surprise discovery that raised new questions about Titan's weather patterns, light, and air structure. These findings could help scientists understand the complex chemistry on Titan and provide clues to life on this distant planet. The search for extraterrestrial life is one of science's most pressing questions, and the James Webb Space Telescope is bringing us closer to the answer. By studying the atmospheres of planets and the environments of moons like Titan, JWST will help scientists identify the places on Earth where life might exist and provide new insights into the conditions where the planet or the moon resides.